Salam, peace be upon you. My name is Muhammad Layak Siddiqui, the father of holophase. We place pattern before object. Phi, pronounced phi, is circular comparability, so only differences, delta phi, are public. Every claim must declare its type, scope, assumptions, and window. Claim, certificate, and artifact are distinct. Local structure is read by lifts, with the carrier A equals d phi tilde. Jets give finite signatures. Cadence omega, texture kappa, and flow nu are readable faces. Domains, boundaries, stitching, winding, holonomy, and defects govern global memory. Identity is lawful equivalence. Persistence is certified survival. Null is disciplined refusal. Dynamics is lawful transformation. Next is certified adjacency. Conservation and generation require source accounting. Provenance carries lineage. Stochasticity is disciplined branching uncertainty. Probability, energy, entropy are derived readouts. Physics is expressed pattern. Observers are patterns. Measurement is interaction producing traces within the measurement certification loop. Part 34. Memory as persistent trace structure in Phi pattern systems. How traces endure, why some fade, and how the past constrains the future. We have reached a moment where everything we built about public knowledge suddenly becomes intimate. Up to now, we have learned how a pattern can be read, how a claim can be certified, and how measurement is not passive looking, but lawful coupling that produces traces. We have also learned that observers are not outside the world. They are Phi pattern systems inside it. So measurement produces traces inside reality, and certification makes those traces publicly usable. Now we face the next unavoidable question. What happens to a trace after it is made? Some traces vanish almost immediately, like a breath on a mirror that disappears in seconds. Others endure, like a scar that stays for life or a fossil that persists for millions of years. The traces that endure do not merely sit there, they change what happens next. That endurance and that future influence is what we call memory. In this foundation layer, memory is not yet meaning, not yet story, not yet thought. Memory is not mystical. Memory is not a special substance. Memory is not a private mental miracle. Memory is simply this: a trace that persists, remains identifiable, stays accessible under some window, and actively constrains future transformation. That is the whole idea. But we must make it rigorous enough to block smuggling and simple enough that it feels obvious. So we will build it the way we have built everything else, with a deep story, concrete examples across scales, and a clean certification discipline. The simplest image, the scar and the bruise. Let us begin with the most human example because it makes the distinction sharp. A bruise is a trace of impact. It appears, it changes color, and it fades. After a while, it is as if it never happened. The body returns near its previous state. A scar is also a trace of impact, but it does not fade. It becomes a new structure in the skin. It changes flexibility, sensitivity, and future healing behavior. The scar constrains the future. So we can already say, a bruise is a transient disturbance. A scar is memory. Both began as traces. The difference is persistence and future constraint. This is the first rule of memory in Phi pattern science. Not every trace is memory. Only persistent, identity trackable, accessible traces that constrain future transformations count as memory. Definition: memory as stabilized modification. Now we say it in one clean sentence that we can pronounce. Memory equals persistent trace structure, a stabilized modification of a Phi pattern system that constrains future transformations. Let us unpack the words, because each word is a firewall. Trace. A trace is an effect of interaction. In part 33, we learned that measurement is lawful coupling that produces traces. The trace is not outside reality. It is a new piece of pattern reality. A footprint in wet sand is a trace. A magnetic bit on a hard drive is a trace. A chemical change in a film photograph is a trace. A neural change after learning is a trace. A mark in a lab notebook is a trace. A crater on the moon is a trace. Persistent. Persistence means the trace survives for a time horizon and survives some range of perturbations and transformations. A trace that vanishes instantly cannot constrain the future. Stabilized modification. Stabilized means it becomes part of the system structure, not merely a passing wave. Modification means the system is now different than it would have been without that trace. Constrains future transformations. This is the most important part. Memory is not inert storage. Memory changes the possibility space. It blocks some paths, enables others, biases future outcomes, shapes recognition, allows learning, and makes prediction possible. So memory is not the past preserved. Memory is the past still acting. What memory requires? 5 certifiable conditions. To keep memory honest, we insist that the memory claim must specify 5 things. We can pronounce them as the 5 memory requirements. 1. Stability, how the trace endures. 2. Identity tracking, how we recognize it as the same trace. 3. Retention under a transformation family, what changes it survives. 4. Accessibility under a declared window, how it can be read. 5. Future constraint, how it changes what can happen next. If any of these is missing, memory becomes a poetic label instead of a certifiable structure. Let us walk through them with examples across reality. 4. Stability, when a trace can survive the world. Stability sounds simple until we realize it always depends on the environment and the transformation family. A footprint in wet sand is stable for hours, maybe days, depending on wind and tide. A footprint in snow might be stable for minutes in sunlight. A footprint in hardened lava could be stable for centuries. So stability is not absolute. It is always stable relative to a declared range of transformations. That is exactly the same discipline we used for identity and persistence. We always declare the relevant transformation family. Example across scales, the moon's memory. The moon has no weather and little erosion, so impacts leave craters that persist for billions of years. The moon is a memory-rich surface because its environment does not erase traces quickly. Earth, by contrast, is an eraser. Wind, water, tectonics, biology. Earth destroys many traces. Earth's memory is selective and precious. So the same event, an impact, yields radically different memory outcomes depending on the transformation environment. Identity tracking, knowing it is the same trace. A trace must remain recognizable as the same trace. Otherwise, we cannot say it persists as memory. A scar changes shape as we grow, but we can still track it as the same scar. A carved mark in a tree stretches as the trunk expands, but we can still track it as the same inscription. A file on a computer may be copied, compressed, renamed, migrated, yet we can still track it as the same artifact by hashes, metadata, or provenance. Identity tracking is the same kind of discipline we used earlier for patterns themselves. Identity is not mystical sameness. Identity is invariance under declared transformations. So for memory we say, a memory trace is the same trace if it stays within a declared identity class under allowed transformations. This connects memory directly to our earlier architecture. Claim identity and artifact identity are not optional. They are what make public continuity possible. Retention under lawful transformation. What does the trace survive? A memory trace must survive some family of transformations. Otherwise, it is not memory relative to that world. A chalk mark on a blackboard survives minutes if someone wipes it. Ink on paper survives years if protected. Etching on stone survives millennia if not destroyed. Magnetic bits survive until overwritten or corrupted. Neural traces survive unless degraded by disease, injury, or decay. So memory is always conditional. Memory is certified relative to a transformation family. We must always say, memory under what conditions, for how long, against what perturbations. This is exactly how we avoid smuggling memory as a vague magical power. Accessibility. A trace must be readable under a window. A trace can exist and still fail to function as memory if it is inaccessible. A fossil buried deep underground exists, but until it is exposed and read, it is not functioning as memory for any observer system. It is potential memory relative to future access. A DNA sequence in a cell is memory only because cellular machinery can read it. A library is memory only because readers can access it. A hard drive is memory only because a system can interpret its encoding. So accessibility means under some declared window and decoding procedure, the trace can be read. This links memory to our earlier discipline. Windows are not optional. If a trace cannot be read under any window we can declare, then it cannot support public claims. Future constraint. Memory changes the possibility space. Now we reach the heart. Memory is not just persistence. Memory is persistence that matters. A scratch on a table persists, but may have no meaningful effect on future transformations. If it changes nothing, no behavior, no function, no decision, then it may be a persistent trace, but not memory in the functional sense. Memory must constrain what comes next. Example, the learned skill. When we learn to ride a bicycle, we do not simply store a picture of riding. We physically modify neural and muscular patterns. Those modifications persist and alter what is possible. Now balancing and steering become accessible transformations. Without those traces, riding is not reachable. With those traces, it is. So memory is literally new adjacency becomes possible because of trace persistence. This is a beautiful unification. Part 27 gave adjacency. Part 33 gave traces from measurement. Part 34 now says persistent traces reshape adjacency. Memory is what bends the map of what can happen next. Transient disturbance versus memory, the pond and the notebook. A stone falls into a pond, ripples spread, then the surface returns to stillness. The ripples were traces, but they did not stabilize. They did not constrain the pond's future behavior in a lasting way. That is transient disturbance. Now a notebook. We write a sentence. The ink dries. The sentence persists. Later, it guides a decision. It constrains the future. That is memory. Same pattern principle, two regimes. A trace that fades is disturbance. A trace that stabilizes and constrains is memory. This distinction is not poetic, it is certifiable because it depends on declared stability, identity, retention, accessibility, and future constraint. 10. Types of memory across the universe. Now we widen the lens, because one of the deepest gifts of this framework is that it refuses to trap important words inside human psychology. Memory exists wherever traces persist and matter. Physical memory, scratches, dents, cracks, magnetic storage, crystal defects that record stress history, chemical changes, developed film, corrosion, geological strata. Biological memory, immune memory, adaptive changes after exposure. Neural memory, synaptic changes. Epigenetic marks, chemical tags that affect gene expression. Muscle adaptation and skill embodiment. Symbolic memory, writing, books, inscriptions, diagrams, maps, equations, music notation, contracts, and legal records. Computational memory, bits in RAM and storage. Model weights in machine learning, logs, databases, version histories, cryptographic hashes linking artifacts. Social and institutional memory, traditions and norms, scientific protocols, standards and measurement units, archives, journals, and citation graphs. All of these are memory because all of these are persistent traces that constrain future transformations. And now we see something profound. Civilization is a memory engine. Science is a memory discipline. 11. Cosmic memory, when the universe keeps receipts. If we want the strongest cross-scale analogy, we look at cosmic traces, because they show that memory is not a human invention. Memory is a structural feature of a world where traces can persist. Tree rings. A tree writes one ring per year. The width and density encode rainfall and temperature. That is a memory trace, stable, identity trackable, readable, and future constraining for science, climate understanding, ecology. Ice cores. Layers of ice trap bubbles of ancient atmosphere. That is memory. The past preserved in matter, readable under a window, chemical analysis, constraining future models. Fossils. A body becomes stone. A trace survives deep time. That trace reshapes what we can claim about evolution. That is memory's future constraint. Cosmic microwave background. The cosmic microwave background is a trace of the early universe, still detectable. It is stable under cosmic expansion, identity trackable by its spectrum, accessible via telescopes, and deeply constraining for cosmology. It is cosmic memory. So the universe is not only evolving, it is recording. And we can now say this in a simple sentence. A world that can be known publicly is a world that can store traces. Memory, provenance, and the public. Now we connect memory to our earlier installed discipline, provenance. Provenance is the memory of a claim. It is the lineage graph, sources, transformations, parameters, toolchain, and history of certifications and refusals. Why did we insist provenance must be first class? Because without memory, public knowledge collapses. If we cannot remember how a claim was produced, we cannot audit it. If we cannot remember what instrument and window generated a trace, we cannot reproduce it. If we cannot remember the transformation pipeline, we cannot locate drift. If we cannot remember dependencies, we cannot propagate revocation. So memory is not merely a topic, it is infrastructure. Memory is the mechanism by which publicness becomes durable. The memory gate, how we certify memory claims. Just as we gave gates for adjacency, conservation, provenance, and stochasticity, we now install a gate for memory. We can pronounce it as the memory gate asks 5 questions. 1. What trace persists? How long and against what perturbations? Stability and horizon. 3. How do we track it as the same trace? Identity tracking. 4. Under what window is it readable and how? Accessibility. 5. How does it constrain future transformations? Future constraint. And we add one protective question. 6. Is it truly memory or merely transient disturbance? If these are not answered, we refuse the memory claim. 14. Firewalls, what we refuse forever. This part blocks common confusions that ruin rigor. We refuse memory as only mental recollection. Memory is broader, any persistent trace that constrains the future. We refuse every trace equals memory. Persistence and future constraint must be shown. We refuse memory without stability evidence. It remembers must cash out in endurance. We refuse memory without identity tracking. If we cannot track the trace, we cannot certify it. We refuse memory without accessibility. An unreadable trace cannot function as memory. We refuse memory without future relevance. If it changes nothing, it is not functioning as memory. These refusals do not shrink the concept, they make it usable. Why memory matters, the bridge to modeling and learning. Once memory exists, something new becomes possible. A system can now carry traces of the world forward and use them to build internal surrogates, internal patterns that stand for external patterns. That is what we will later call modeling. Without memory, every moment is isolated. There is no accumulation, no learning, no refinement, no science. With memory, the world gains a new power. The past can shape the future through persistent structure. And that is the deep philosophical point that stays simple. Memory is not a ghostly faculty. Memory is stabilized trace. Trace is born from interaction. Interaction is lawful coupling. Coupling produces public artifacts. Artifacts accumulate into method. Method becomes civilization. So part 34 completes an essential arc, from measurement traces to durable public knowledge. Closing story: wet cement versus flowing water. Let us end with one last image that we can carry. Flowing water takes a shape for a moment and then forgets it. That is disturbance. Wet cement takes a shape and holds it. That is memory. Reality is full of both. Some parts of the world are like water, constantly washing away traces. Other parts are like cement, holding traces long enough for history to become structure. And wherever history becomes structure, the future is no longer free to be anything. The future becomes constrained by the past. That constraint is not a prison. It is the condition for learning, for identity, for knowledge, and for science. Now that we have memory, we can finally ask the next question. When a Phi pattern system carries memory, how can it build an internal pattern that stands in for another pattern so it can anticipate, predict, and act? That is part 35, modeling. When a Phi pattern builds an internal surrogate of another Phi pattern. Always, peace be upon you.